Hello everyone, welcome to the first lecture of trigonometric functions. Let us understand how to measure angle. Let's understand how to measure an angle in trigonometry. First, let us draw a ray. I name this ray OA. Now, I'm going to rotate this ray from the point O like this, and let's name this ray now OB. Now, this is the original ray. We name it initial side. Now, the position attained by the original ray after rotation is called the terminal side. So, OB will be the terminal side. Now, this ray has been rotated in anti-clockwise direction, and O here is the vertex. O is the vertex here. If the rotation is in anti-clockwise direction, the angle will be positive angle. Now suppose there is another line or another ray, we name it OC, and this line is rotated now in clockwise direction. We call this ray OD. Now this line OC becomes the initial side, and OD is terminal side, and the rotation is clockwise direction. It is in clockwise direction. So this will be negative angle. This is negative angle since this is rotated in anti-clockwise direction. There are two types of angle measurement. First one is degree measure, and the second one is radian measure. Now let us understand how to measure in a degree. What is degree measurement? Suppose there is a ray OA and we rotate this and bring it back to the same original position, so that here the initial side and the terminal side, initial side and terminal side both are same. If the initial side and the terminal side both are same, it has been rotated by 360 degree, and the rotation makes a complete circle. The rotation makes a complete circle. Also, the complete rotation by 360 degree makes one revolution. Now, how will you define 1 degree? How will you define 1 degree? See, if if the rotation if the rotation is 1 by 3/60th part, 1 by 3/60th part of a complete revolution, it will be 1 degree. Similarly, 2 degree is 2 by 3/60th part of the complete revolution, and so on. Also, 1 degree equals to 60 minutes, which is written as 60 dash, and 1 minute equal to 60 seconds, written as 60 double dash. Let us understand what is radian measure. First of all, what is 1 radian? So here see, this is a circle whose radius is 1 unit, and I have taken an arc here whose length is also 1 unit. So the angle subtended by this arc at the center will be 1 radian. So here you can see 1 radian. 1 radian is the angle subtended by an arc at the center of a circle whose length is equal to the radius of the circle. If we have the same, suppose we have radius r here, and we take a length of an arc r unit, then it will subtend an angle of 1 radian at the center of that circle. Now, suppose I take another arc on the same circle whose length is 2 units. Then this arc will subtend an angle at the center whose measure will be 2 radian. So here we can clearly see that keeping the radius constant, if we increase the length of the arc, the measure of the angle increases. Denote the angle subtended by the arc as theta and length of the arc be L. So as we have seen here, the theta increases on increasing the length of the arc. This means that theta is directly proportional to the length of the arc. Consider this arc BC once again, whose length we keep constant, and now increase the radius twice. Then this arc would have subtended an angle whose measure would be 1 radian. That means the theta is inversely proportional to the length of the radius. So that means from both of these two equations we can derive a formula which is theta equal to L by R, or L equals to R times theta. Now see here, I have taken a circle whose radius is 1 unit. So what will be the circumference of this circle? the circumference will be 2 pi. Okay. Now suppose in this circle I take an arc whose length is actually equal to the circumference of the circle. So the arc length here is 2 pi. So what will be the angle subtended by this arc at the center of the circle? By the formula we get theta to L by R. Here L is the 2 pi, the whole circumference, and radius is 1 unit. So the angle subtended will be 2 pi radian. Now suppose I take a ray here whose one end is at the center. Let the center be O, and here the other end is touching the circumference or the boundary of this circle. Let's name this point A. Now if I rotate this ray in such a way that it completes one revolution of the circle, such that its initial side and the terminal side are same, then this will be rotated by 360 degree, right? And what is the angle subtended at the center by the whole circumference? That is 2 pi radian, which means that 2 pi radian is equal to 360 degree, which means pi radian is equal to 180 degree, which means 1 radian is equal to 180 by pi degree. Now let's understand how to convert an angle from degree to radian measures. Suppose we want to convert 30 degree into radians. So we know that pi radian equals to 180 degree, which implies 1 degree equal to pi by 180 radian. This means 30 degree equal to pi times 30 by 180. Now cancelling this, we get 30 degree equal to pi by 6 radians. Now suppose we want to convert 60 degrees into radians. We know that 180 degree equal to pi radian. So 1 degree will be pi upon 180 radians. So 60 degree will be pi times 60 upon 180. Simplifying this, we will get pi by 30 radian. Sorry, not pi by 30. This will be pi by 3 radians. Now let us try to solve some questions from NCERT. The first example is convert 40 degree and 20 minutes into radian measure. First we need to convert this 40 degree and 20 minutes into degree. So here we know that 60 degree equal to 60 minutes equals to 1 degree, which means 20 degree equal to 1 upon 60 times 20 degree. By this we get 1 by 3 degree. So 40 degree 20 minutes is equal to 40 1 by 3 degree. Simplifying this we get 121 by 3 degree. Now we need to convert this into radian. So we know that 1 degree equal to pi upon 180 radian. Therefore 121 by 3 degree is equal to pi multiplied by 121 upon 180 into 3, which means 121 by pi upon 540 degree. See the next question. Convert 6 radians to degree measure. See the next question. Convert 6 radians into degree measure. Now we know that 1 radian is equal to 180 by pi degree. So 6 radian equal to 180 into 6 upon pi. Simplifying this we get 1080 upon pi. Putting the value of pi here we get 1080 into 7 by 22. This becomes 0, 28, 2, 25, 3780 upon 11. Now let's simplify this. This is equal to 343 into 7 upon 11 degrees. Now let us convert this 7 upon 11 degree into minutes. Now we know that 60 minutes equal to 1 degree. This implies 7 upon 11 degree will be equal to 7 into 60 upon 11 minutes. This is equal to 420 by 11. Now simplifying this we get this is equal to 38 into 2 upon 11 minutes. Let's convert this 2 upon 11 minutes into seconds. Now we know that 60 seconds equal to 1 minute. Therefore 2 upon 11 minute is equal to 2 into 60 upon 11 seconds. Now this is equal to 120 upon 11. Which is equal to 11 approximately. Therefore 6 radian equal to 343 degree 38 minutes and 11 seconds. See the next example. Find the radius of the circle in which angle of 60 degree intercepts an arc of length 37.4 centimeter. Let's solve this question. Here we have given circle where the central angle is 60 degree which is subtended by an arc. So here theta is equal to 60 degree. Here given the length of the arc is 37.4 centimeter, which means L equal to 37.4 centimeter. Now we know the formula that L equals to R times of theta. Here we are given L is equal to 37.4, R we need to find out, and theta is 60 degree, which means 37.4 equal to R times, we need to convert this into radian, which will become pi by 3. Now we need to put the value of pi here, which is 22 upon 7, which means R is equal to 37.4 into 3 into 7 upon 22. Let us simplify this. So the radius of the circle will be 35.7 centimeters. Now see, this one is a good question. The minute hand of a watch is 1.5 centimeters long. How far does its tip move in 40 seconds? Now if you see this question carefully, you can understand that the watch is actually a circle and the minute hand of the watch is actually the radius of this circle. And the distance the tip of the minute hand is covering is actually the arc of the total circumference of this watch. Now see, in 60 minutes the minute hand completes one revolution, which means the angle subtended at the center will be 2 pi in 60 minutes. Therefore, in 40 minutes, the angle subtended will be 2 pi upon 60 into 40, which means 4 pi by 3 radian will be subtended at the center in 40 minutes. Also, the minute hand is 1.5 centimeter long, which means R is equal to 1.5 centimeter. Now from the formula L equals to R theta, we get L equals to 1.5 into 4 pi upon 3. Simplifying this, we get 2 pi by 3. Simplifying this, we will get 2 pi centimeter. Now putting the value of pi as 3.14, we get the arc length equal to 6.28 centimeter. So in 40 minutes, the tip of the minute hand will move 6.28 centimeter. See the next question. If the arcs of the same length in two circles subtend angles 65 degree and 110 degree respectively at the center, find the ratio of their radii. So according to the question, we have two circles where the same length arc subtend two different angles at the center, and we have to find the ratio of their radii. Suppose we have two circles now. The radius of the first circle, let's say R1, and let's say the radius of the second circle is R2. Now BC is an arc and DC is an arc on the two different circles who have the same length according to the question. Let us take that length as L, and they subtend theta 1 and theta 2 degree at the center of their respective circles. Now we have to find the ratio of R1 to R2. Now according to the question, we have theta 1 equal to 65 degree and theta 2 equal to 110 degree. Now we have to convert this into radian measure. So theta 1 equal to 65 into pi by 180 radian. So we have to simplify this. We get 13 pi by 36 radian, and theta 2 equals to 110 into pi upon 180. This will be equal to 11 pi by 18. Now we have to find the ratio of the two radii. By the formula, L equals to R theta, we get R1 theta 1 equal to R2 theta 2, because the arc length is same in both the circles. It is given in the question. So by solving this, we get R1 multiplied by 13 pi by 36 equals to R2 into 11 pi by 18. Simplies R1 by R2 equals to 11 pi by 13 pi into 36 by 18. So pi will be cancelled out. So we get R1 by R2 equal to 22 by 13. Therefore, the required ratio is R1 is to R2 equal to 22 is to 13. Now let us solve the questions from exercise 3.1. See, the first question is, find the radian measures corresponding to the following degree measures. 25 degree, minus 47 degree 30 minutes, 240 degree and 520 degree. Now let's solve the first one. So we know that 1 degree equals to pi upon 180 radian. So 25 degrees equal to pi by 180 into 25. So solving this we get 5 pi by 36 radian. See the second one, minus 47 degree and 30 minutes. Here there is a minus sign, which means that the angle is measured in clockwise direction. Now first we need to convert this 30 minutes into degrees. Now we know that 60 minute equals to 1 degree and 1 minute equal to 1 by 60 degree. So 30 minutes will be equal to 30 by 60 degree, which means half degree. So we need to find the radian measure of minus 47 and half degree, which is equal to minus 95 by 2 degree. Now we know that 1 degree is equal to pi by 180 radian. Therefore minus 95 by 2 degree is equal to minus pi by 180 into 95 by 2. Simplifying this we get minus 19 pi by 72 radian. Third question is 240 degree, which will be equal to pi upon 180 into 240 radian. Simplifying this we get 4 pi by 3 radian. The fourth one is 5 by 20 degree, which is equal to pi by 180 into 520 degrees. By simplifying this we get 26 pi by 9 radian. Now see the next question, minus 4 radian, which is equal to minus 4 into 180 by pi degrees, which is equal to minus 4 into 180 into 7 by 22. So solving this we get So here it is 0 minus 2520 upon 11. This will be equal to 229 and 1 upon 11 degree. Now we need to convert this 1 by 11 degree into seconds. So 1 by 11 degree is equal to 60 by 11 degree, which will be equal to 5 and 5 upon 11 minute. Now we need to convert this 5 upon 11 minute into seconds. So 5 by 11 minute is equal to 5 into 60 upon 11 seconds, which is equal to 300 upon 11, which is approximately 29 seconds. Therefore, minus 4 radian is equal to minus 229 degree 5 seconds and 20 sorry minus 229 degree 5 minute and 29 seconds. Now see the next one. 5 pi by 3 radian. 5 pi by 3 radian equal to 180 by pi into 5 pi by 3. So pi and pi goes cancelled. 3 times 60 is equal to 180. So this is 300 degree. The next one is 7 pi by 6 radian. Therefore 7 pi by 6 is equal to 7 pi by 6 radian is equal to 7 pi by 6 into 180 by pi degrees. Pi goes cancelled out. 6 times 30 is 180. So this will be 210 degree. See the next question. A wheel makes 360 revolutions in 1 minute. Through how many radian does it turn in 1 second? See, according to the question, the wheel makes 360 revolutions in 1 minute. Therefore, which means in 60 seconds the wheel makes 360 revolutions. So in 1 second it will make 360 upon 60, which is equal to 6 revolutions. Now in 1 revolution the wheel rotates by 2 pi radian. Therefore, in 6 revolution, the wheel will rotate by 2 pi into 6 equal to 12 pi radians. Now see the question. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeter by an arc of length 22 centimeter. Let's solve this question. Now here we have a circle. In this circle, the radius given is 100 centimeter. Now the question says that we have an arc, say AB, whose length is 22 centimeter, and this arc subtend an angle, let's say theta. So we have to find the value of theta, or the angle subtended at the center by this arc. Now we know the formula. We know that L equals to R times theta, where L is the length of the arc, R is the radius of the circle, and theta is the angle subtended at the center. Now we are given L is 22 centimeter, the radius is 100 centimeter, and we have to find the theta. So theta is equal to 22 by 100 radian. Now we have to convert this into degree measure. Therefore, 22 by 100 into 180 by pi degree. By putting the value of pi, we get 22 upon 100 into 180 into 7 upon 22. So 22 and 22 goes cancelled out. Is 12 into 3 by 5 degree. Now we need to convert this 3 by 5 degree into minute. Therefore 3 by 5 degree is equal to 3 into 60 by 5 minutes, equal to 36 minutes. Therefore the theta is equal to 12 degree and 36 minutes. See the next question. In a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. Find the length of the minor arc. Given that there is a circle whose diameter is 40 centimeter, therefore the radius or r is equal to 20 centimeter. Now the circumference of the circle will be 2 pi into 20 centimeter, which is equal to 40 pi centimeter. Now let AB be a chord whose length is 20 centimeter. So now AB will be the minor arc here. Now let the center of the circle be O. Now consider the triangle AOB. Here OA and OB will be 20 centimeters since it is the radius of the circle. Now triangle AOB is an equilateral triangle and all the angles in the equilateral triangle are 60 degree. So angle AOB is equal to 60 degree, which means pi by 3 radian. Now applying the formula L equals to R times theta, we get R equal to 20 centimeter and theta is pi by 3. For L equals to 20 pi by 3. Therefore the length of the minor arc is 20 pi by 3 centimeter. Now see the next question. If in two circles arcs of the same length subtend angles 60 degree and 75 degree at the center, find the ratio of their radii. Now suppose we take two circles whose radius are r1 and r2 respectively. Now according to the question, arcs of the same length subtend angles 60 degree and 75 degree. Suppose we take here a chord AB and here we take a chord CD. Now according to the question, their lengths are same. Let the length be L. Now they subtend an angle at the center 60 degree and 75 degree. Now 60 degree is equal to pi upon 180 multiplied by 60 degree, which means pi by 3 radian, and 75 degree is equal to pi by 180 into 75. Simplify this now. We get 5 pi by 12 radian. We know the formula R L equal to R times theta. Therefore R1 theta 1 is equal to R2 theta 2. This implies R1 by R2 equal to theta 2 upon theta 1. Here theta 1 is 5 pi by 12 and theta 1 is pi by 3. Now we can cancel this out. Pi gets cancelled 3 times 4 is 12. So the ratio is 5 by 4. Therefore, R1 is to R2 equal to 5 is to 4. See the next question. Find the angle in radian through which a pendulum swings if its length is 75 centimeter and the tip describes an arc of length 10 centimeter, 15 centimeter and 21 centimeter. Now let's start solving. Here the tip describes an arc of length 10 centimeter. Therefore, we have L equal to 10 centimeter. Also, the length of the pendulum is 75 centimeter. Now, the length of the pendulum actually describes the radius of the arc. So, the radius R is equal to 75 centimeter. Now, by the formula L equals to R times theta, we get 10 equal to 75 times theta. Therefore, theta is equal to 10 upon 75, which is equal to 2 by 15 radian. Now see the next question. Here L is equal to 15 centimeter. Therefore, by formula L equal to R times theta, we get 15 equal to 75 times of theta. Therefore, theta is equal to 15 upon 75. Dividing both numerator and denominator by 5, we get 3 by 15, which means 1 upon 5 radian. Now see the third one. Here the L given is 21 centimeter and the radius is 75 centimeter. Therefore, theta will be 21 upon 75 radian, which is equal to 7 upon 25 radian. Thank you so much for watching this video. Make sure you share it with your friends and let me know how was the video in the comments.